Welcome to our presentation on Introduction to Refining. KLM Technology Group, based in the USA since 1995. KLM is a technical consultancy group providing specialized services and equipment to improve process plant operational efficiency, profitability, and safety. Training. Today we're discussing Introduction to Petroleum Refining. We also offer training classes in Advanced Petroleum Refining for technical professionals, Advanced Crude Unit Troubleshooting, Refining for Operations, Refining for Troubleshooting for Operations, Refinery Catalytic Processes, and Refining for non-technical professionals, as well as other process units and equipment groups. Most of the courses are 3 to 5 days. The course descriptions can be found on the website, klmtechgroup.com/training. The Kolmetz Handbook of Process Equipment Design. In 2007, we began writing the Kolmetz Handbook of Process Equipment Design. There are multiple chapters for petroleum refining design in the handbook. We have over 50 chapters on a wide range of subjects. Each chapter is 70 to 160 pages, including design and sizing guidelines. The handbook may be found here, KLM Tech Group /engineering design guidelines. Some of the refining chapters include general distillation column, 93 pages, a desalter, 67 pages, a crude tower, 164 pages, a vacuum tower, 136 pages, FCC unit, 98 pages, hydrotreater units. One of our best-selling is hydrotreaters, 70 pages. Refinery catalytic reformer, 90 pages. BTX extraction unit, 75 pages. Refinery furnace, that one sells well, 185 pages. Other chapters include reboilers, flares, tanks, and waste management. Introduction to Refining. We're going to cover the Introduction to Refining in 2 parts. I was going to make it one presentation, but then the presentation got very long, so I said, well, we'll break it into 2 parts. Part 1 we'll cover today: crude unit properties, atmospheric crude towers, vacuum towers, DAO towers, and coker units. Part 2 we'll cover hydrodesulfurization units, refinery catalytic reformers, refinery FCC units, refinery alkylation units, refinery isomerization units. How did this industry begin? Bitumen or asphalt seeping to the surface, used as a binding material, lining water canals, sealing joints in boats, and lighting in the Middle East as far back as 3000 BC. Petroleum encountered when digging salt wells in China in 200 BC and used for lighting and fuel. Petroleum industry developed in Eastern Europe as early 1900s. Shafts were dug by hands. Primitive oil in Pennsylvania in the mid-1900s, gathering for surface oil, process developed for the production of the lighting fluid termed kerosene in 1954. First scientific investigations into the properties of petroleum carried out by American chemist Benjamin Stillman Jr. in 1855, and sometimes distillation columns are still called stills, and the operator that operates the distillation column sometimes is called a stillman. Around 1830, the Chinese method of salt boring or drilling imported into Europe and the United States. Salt boring technique adapted to drill the first oil well in Pennsylvania in 1859, and the oil was transported in barrels with volume standardized to 42 gallons in 1866. And a normal size drum in the U.S. is 55 gallon that you see, but barrels are bought and sold in 42 gallon barrels. The earliest days of the oil industry, they distilled oil to get the kerosene for lamps. The lighter than kerosene and heavier fractions were thrown away, typically in a waterway. Later, when automobiles created a market for gasoline, the lighter fractions became more valuable. The lights were still thrown away, the gasoline went to cars, the kerosene went to lamps, the fuel oil was used as ship fuel. 1920 to 60s, processes were developed to convert the low-value fractions into higher-value products. Processes were also invented to improve the product properties. Petrochemicals grew rapidly from the mid-20th century. The refinery has evolved from a simple boiling operation into the complex plant we see today. Refinery products. Fuel gas, the light ends, can be fuel or chemical composition. Gasoline's motor. Untreated gasoline is called naphtha. It can be a chemical feedstock. Jet fuel is now the major use of kerosene. Is now jet fuel. Diesel fuels can be used for large trucks, can be used in the railroad and the marine transportation. Lubricating oils, machine lubrication, white oils, sometimes called heavy naphtha or CMS. Waxes, bitumen called asphalt, petroleum coke, can be used as a fuel, can be used in electrodes for electricity or for metal manufacturing. There are different types of refineries have evolved based on the type of crude oil. Some types of crude oil are very good for fuels. Some types of crude oil make coke very well. Some types of crude oil make lubricants. In Pennsylvania, the type of crude oil there makes very good lubricants. In Malaysia and Thailand makes very good lubricants. Some types of crude oils are very good feedstock for petrochemicals. Different types of feed for low sulfur, for high sulfur. So you have to design the refinery different for different types of feed. Heavy, light, low. Refining is the second largest chemical industry, only superseded by ammonia production. Almost every country in the world has ammonia production because the ammonia is then used in fertilizer. Refining contains almost every unit operation and is a challenging yet rewarding occupation. Refining is an organized and coordinated arrangement of unit operations designed to provide physical and chemical changes to petroleum crude oils. This is kind of the map we're going to use today to walk us through what we're doing. We're going to talk about crude properties. We're going to talk about the atmospheric tower. Then the bottom of the atmospheric tower goes to the vacuum tower. The bottom of the vacuum tower goes to the DAO. And the bottom of the DAO unit goes to the coker. So the crude unit takes the lighter components out. The vacuum tower takes some more of the heavier components that still have value, and the DAO takes the last of the valuable components out. We look at things by carbon numbers. Carbon numbers are the length of the number of carbons that are in that molecule. The light ends have 1 to 4 carbons. Naphtha, which is later converted to gasoline, has 5 to 10. CMS is the white oil, can be a heavy naphtha. Kerosene, typically today, is used mostly for jet fuel, diesel. AGO can be 9 to 17. Light vacuum gas oil, heavy vacuum gas oil, and DAO. So these are the rough carbon numbers of each one of these. Petroleum is not an element or even a compound, but it's a mixture of related chemical compounds called hydrocarbons. In its natural state, it varies in appearance from whitish clear liquid through brown or green all the way up to black. Hydrocarbons are the basic and most important family of the organic class of compounds. Thousands of different compounds from very light C1s all the way down to C80 may be found as crude, or it may be associated with natural gas. As the number of carbon atoms increase, the material becomes heavier, and the boiling point and the specific gravity increases. Above 17 carbon atoms, the compounds are a solid. So 1 to 4, they're at room temperature, they're typically a gas. 5 to 10, that's the gasoline range. They're typically a clear liquid. 10 to 15, they can be a brown, and above 15 to 17, they're black. So here is the weight percent of sulfur in the crude. All right, so we have if we have 0.5 weight percent sulfur in the crude, the naphtha is about 0.5%. But if you look as we go down the heavier products, the percent of sulfur gets heavier. So what happens is the sulfur is mostly in the heavier products. All right, and so as we process more heavier crudes, we even have a larger need to remove the sulfur. High crudes are more difficult to refine and may require special equipment. A sweet crude is less than 0.5. A sour crude can be greater than 2.5 weight percent sulfur. Houston Refinery. This was the refinery where I worked 16 years in Houston, Texas. I worked 11 years on the naphtha reforming in the middle distillates area. I worked about 3 years. We had a BTX, solvent extraction unit. I worked about 3 years there. Worked a year and a half in the crude distillation, vacuum distillation in the Rose unit. Rose is a name brand for the DAO unit. So we'll talk today. We're going to talk about crude distillation, vacuum distillation, Rose unit. This particular refinery did not have a coker. Crude oil types. Density may be light, intermediate, or heavy. One of the best known benchmarking crudes is called West Texas Intermediate. Lighter crudes are easier to process than high-value products. Heavier crudes are more difficult to process and may make less of the high-value products. West Texas Intermediate. This is typically what's quoted there on the price of crude. There's two typical crudes that are quoted on the price. West Texas Intermediate, and the other one is Brent, North Sea Brent. West Texas Intermediate has 1.5% light gases. It's about 25% naphtha, 10% kerosene, 21% gas oil, 41% fuel oil. Now, what we want to do in the refinery, we want to take this 41% fuel oil and we want to convert it back into the higher value products. Now, most of my career, naphtha and gasoline were the highest value product. Today, gas oil, which is diesel, has become more valuable. So we're changing how we actually operate the refineries today because of the economics. What is this industry? All right, so we can take crude out of the ground. It can be a mixture of crude and a mixture of gas. Some wells are predominantly natural gas, some wells are predominantly crude, some can be a mixture. So what you do at the wellhead, you separate the natural gas from the crude oil. That can be done easily in a single separator. You send the natural gas to the gas separation units, you send the crude oil to the refinery. So you send the crude oil to a refinery, you make diesel, you make fuel oil, you make gas oil, you make naphthas. You reformer, you can make a BTX. The natural gas, you go to a gas separation unit. You make ethane, propane, LPG, condensate, methane. Methane can be used as heating for housing. Propane can be used for bottles, for compressed gas bottles. You can go to a steam cracker. I can make additional, or we can go to BTX extraction. So there's kind of a basic petrochemical flow scheme. So we're going to use this map today. So we've talked a little bit about crude oil properties. We could talk several days about each one of these sections. We could talk several days about crude oil properties. We could talk several days about atmospheric tower. The function of a atmospheric crude tower is to distill, to separate with heat, the lighter and the more valuable portions of the crude. The crude should be processed safely, economically, environmentally, and reliability. This is very difficult. A lot of people think this is easy, but it's not. Reliability means to be able to run and process more than 4 years, and you really want to be able to run about 5 years. And you're dealing with asphalt, you're dealing with all kind of impurities and things that foul. So to be able to run reliably is very important. If you go research, there are many people who list themselves as crude unit designers. But there's only a very small group that I actually trust. The first question you might want to ask a crude unit expert is how many running towers you have designed and commissioned. A good answer might be 10 to 20. Many of this group have only one, and it most likely did not function well. I've been asked to troubleshoot crude towers, and I've come in and looked at what people's designed, and I'm going, well, this probably was their first crude tower. The second question you might want to ask for a list of people, more than one, a list of people that would recommend them. All at once, the list of crude unit designers gets very small. We'd be very happy to recommend a qualified crude unit designers to review your project. If you have a small project, a P&ID and distillation equipment review would be wise. If you have a large project, you should bring them in early in the project. One of the places I found a lot of errors in crude tires is in the hydraulics of the distillation and packing. So what we're going to look at, we're going to start a very simple overview, and we're going to get progressively deeper. So a simple overview of a crude unit: I bring crude in, I heat it, and then I flash it into vapors. The vapors go up the column. As I go up the column, I progressively cool the vapors, and I pull off the different cuts. So I go in, I progressively cool it, the fuel oil comes off, then the diesel comes off, the kerosene comes off, then the gasoline comes off. Here's a little more detailed picture. I have heat recovery. I come into a desalter. Okay, a desalter removes the salt. If I don't remove the salt, the top of the tower and the overhead separator will corrode due to the salt. So I need to remove the salt. I go into more heat recovery. I go to the furnace, and I've got the little pump arounds where I'm cooling them off, and I'm progressively removing the heat. Okay, and so I have atmospheric gas oil. I've got what's called straight run diesel, straight run kerosene, straight run heavy naphtha, and the overhead is light naphtha. Now there are many different draws. There's really many different types of crude tire arrangements. They're typically designed for a particular crude slate. So you have a certain crude slate, you design the column for it. But you also want to build some flexibility in so you can run other crude slates. A little more complex picture. I come in to the crude pump here. Crude oil comes into the pump. I go through a heat exchanger. I go through some other heat exchangers. I go to the desalter. I go back to the heater. I go to the crude distillation column. I pump it out. So the Kolmetz Handbook has a chapter on each piece of equipment on this page. We got a chapter on pumps. We got a chapter on heat exchangers. We got a chapter on desalters. We have a chapter on refinery furnaces. We have a chapter on crude towers. We have a chapter on fin fans. We have a chapter on separators. So everything on this page, the Kolmetz Handbook has a chapter on. This is a P&ID, complex P&ID of two of the heat exchangers. Okay, so you got very simple, a little more detail, and then very detailed. And then there's the detail beyond this of how to design heat exchangers. So here's what they look like in real life. The one in the middle is the crude tower. The one on the right, the shorter, fatter one, is the vacuum tower. Fractionation trays. If I go to inspect a column, crude column, this is what I want to see. At the bottom of the tower, I want to see a vapor distributor. I want to see the trays in place. I probably don't want to look and find a picture like this where all the trays are laying in the bottom of a column. Very important. You design the trays with proper support and proper hydraulics. Vacuum tower. So we take the bottom of the atmospheric tower, we go to the vacuum tower. The function of the vacuum tower is to distill, again, separate with heat at low pressure, some of the remaining valuable products of the crude. The crude tower does not remove 100% of the valuable portions, so we then process them again in the vacuum tower. The crude, again, should be processed safely, economically, environmentally, reliably. This is a very difficult task. Reliability may be able to run and process more than 4 or 5 years, and you really want 5 years. The vacuum tower has one of the highest failure rates in distillation. You won't find nearly as many people who claim they're vacuum tower experts because it has a very high failure rate. So what we do, we come in through the crude tower, we go to a heater, we go to a vacuum column. Now, because we want it to run reliability, we don't want to make any coke in these columns. All right, so we heat the bottom of the crude tower up to a temperature where it will not make coke, but that still leaves some valuable products in it. So then we go to the vacuum tower, we heat it up under very low pressure, and we get a little more of the valuable products out. A heavy vacuum gas oil, light vacuum gas oil. So so we heat it up under about 20 pounds pressure in the atmospheric column, and then we pull a vacuum and we heat it some more to try to pull the valuable products off. Here's a picture of the refinery where I worked in Houston for 16 years. The one on the right is the crude tower. The short fat one in the middle is the vacuum column. And so I was the process engineer over this unit for about 1.5 years. Vacuum tower, I come in, I add steam. I can add steam. If you add steam, it's called wet. If you don't add steam, it's called dry. You pull with steam ejection, or maybe a ring compressor. You pull a vacuum, and the bottoms, it's called vacuum resid, which is mostly asphalt. And then I make a heavy vacuum gas oil and a light vacuum gas oil, and then I have a couple of pump arounds there. A little more complex, okay? A little more complex drawing, and here is a even more complex drawing. This is a P&ID, and then we get into how the tower internals are designed, and that is very important, how the tower internals are designed. And we have a large paper on vacuum tower design, and we have 3 chapters on tower internals, how they're designed. Vacuum column looks like this. This is probably not a picture you want to see. You don't want to see a pickaxe and a jackhammer trying to remove the structured packing because you have coke, the wash bed. This is very common if you don't design them properly. I had a friend, this was from South America, I had a friend, someone who didn't know what he was doing, designed this one. It coked in about 6 months. One of my friends came behind him, and it lasted about 4 years just by changing the parameters around this wash bed. Next, we'll talk about DAO tower. The function of a DAO unit is to remove the remaining higher value products from the asphalt. The feed is combined with the solvent, and the deasphaltene oil is removed by the solvent. The solvent is recycled, recovered and recycled. The asphalt can then be routed to storage for sales, or can be routed to a coker unit. Further separation of vacuum resid by distillation without decomposition and making coke is difficult. Solvent extraction can be used instead of distillation to make DAO. So I take solvent, I mix it, then soluble asphalt goes out the bottom, the soluble deasphalted oil goes overhead. The oil, the asphalt DAO can then go to an FCC or fuel oil sales. The solvent is recycled back. And here's a little more complex picture. A friend of mine wrote an article in Engineering Practice magazine about solvent deasphaltene, and this was a picture from Engineering Practice magazine. A coker unit. The function of the coker is to crack with heat the asphalt into the higher value products. So in the coker, I actually want to make coke. Where in the other units, I really don't want to make coke. The feed is kept at high temperature for a longer period in a coking drum, producing cracked products and coke. It has multiple coking drums where the feed is cracked, can be taken offline, and then the coke is removed with high pressure water. So what do we have here? We have the feed coming in from the bottom. We go in the bottom of the tower. It's pumped through a heater. It goes to the active coking drum. It's recycled back. In the coking drum, it's high temperature. For higher residence time, it cracks into coke and lighter products. The overhead vapor comes out. The lighter products go up the tower. They're pulled off as coker gas, gas oil, and wild gasoline. The heavier products is again recycled back through the heater in the coke drum. When this coke drum gets full, you switch to the other coke drum. You steam off any free hydrocarbons, and then you take a high pressure water blaster and cut the coke out. So that's how it works. A little more complex picture. You got 4 drums, you got the quench tower, you've got 2 heaters, and what do they look like in real life? Here we have 4 coke drums with the water blasters on top. Here we've got 3 heaters, and you can see the quench tower setting in the background on the picture on the right. So what have we talked about today? We've talked about crude oil properties. We've talked about an atmospheric tower, a vacuum tower, a DAO, and coker. We could spend 3 to 5 days probably talking about each one of these areas. Crude properties, atmospheric towers, vacuum towers, DAO, coker unit. Part 2, we'll talk about hydrotreaters, catalytic reformers, FCC units, alkylation unit, isomerization units. Thank you for your time today. If you need a consultant, would be happy to nominate a very senior level consultant to assist you. If you're interested in more details, you can review the Kolmetz Handbook of Process Equipment Design, and we'd be happy to come to your house and provide training for your staff. All the best in your career in life.